my first question is actually going to turn into two. My original question had just been, Blue Origin is actually aiming to launch people in the coming year. Part two of that is just a couple hours ago came out. You're planning a moon mission, a moon lander as well. So you want to tell us about both of those?
Okay. Two very different things. We've been working for several years on a program called New Shepard, named after Alan Shepard, the first American in space. It is a suborbital tourism mission. It's a vertical takeoff, vertical landing vehicle, powered with liquid hydrogen, liquid oxygen, 110,000-pound thrust BE-3 engine that we developed over a number of years and flight qualified. We've flown it several times now. It's a glorious thing to see fly, as most flying objects are. And we have tested the escape system. The parachutes for the crew capsule have been designed so that if only one of the parachutes come out, it's still a safe vehicle. It separates in space from the booster. The booster comes back and lands vertically. The crew capsule comes back. The crew capsule has the largest windows that will have ever flown in space. It's designed from the beginning to be a tourism mission. And people say, the astronauts, those few people who have been lucky enough to go into space, say that when you see the thin limb of the Earth's atmosphere and see that view of the Earth from space, that it does change you. It makes you recognize just how fragile and amazing this planet is. So we hope to be able to provide a lot of people with that experience. And then what you're referring to, the new thing, is that we are hoping to partner with NASA on a program called Blue Moon, where we would provide a cargo delivery service to the surface of the moon with the intent over time of building a permanently inhabited human settlement on the moon. So it's time for America to go back to the moon, and this time to stay. We can do it. It's a difficult but worthy objective. And a lot of the technology that we've been developing for the New Shepard program, the liquid hydrogen engine, an upper stage variant of that, becomes the transfer stage to get to the moon. Our architecture can fly on top of SLS on the high end, or it can fly on top of the Atlas 551. And deliver more modest payload to the surface of the moon. So it's a very exciting time, I think. I think we have a chance to really inspire a bunch of young people, build a permanent establishment on the surface of the moon. We now know that the moon has water ice, which is a very big deal. You can make propellant out of it. You can make life support materials out of it. We know now that there are peaks of eternal light or nearly continuous light on the rim of Shackleton Crater on the South Pole. You also get thermal stability there. So it's a very exciting idea to go to the moon and really explore it, to go to stay. And that, in my view, is the fastest way to get to Mars, which is also a very glamorous and exciting destination. But I think that if you go to the moon first and make the moon your home, then you can get to Mars more easily.
Great. Why is reusability so important, to achieving your vision? I mean, you got the award tonight for reusability.
Reusability is a key. In my view, what I hope to see, I have, over the last 20 years on the internet, I have witnessed something extraordinary. 20 years ago, I was driving the packages to the post office myself. And Amazon has grown into this gigantic company that serves customers all over the world. We work very hard to do that. But the reason that Amazon has succeeded, and the reason that so many internet companies have succeeded, and the reason that you see that entrepreneurial dynamism on the internet, is because so many thousands of startup companies can participate. And that's because the cost of admission is very low. Two kids in a dorm room can start an internet company. And so every experiment gets done. Space is very different today. The difference with space and the internet today is that the cost of admission to do something interesting in space is actually quite high. It takes, some small number of hundreds of millions of dollars to do something interesting in space. And 2 kids in a dorm room can't do that. In fact, not even an average startup company can do that. Even a well-funded startup company can't do that. So very few experiments get done. And what I really want to see happen is I want Blue Origin to lower that cost of entry. We've got to work on lowering the cost of launch into low Earth orbit, because that's where creativity gets unleashed. There isn't a lot of benefit to creativity when you're trying to get from the surface of the Earth into low Earth orbit. There are only a few ways to do it. They're well understood, and they're all super expensive. And so creativity gets you only so far. And what we would like to do is dramatically reduce that price of admission so that there can be a big entrepreneurial group of people operating in space, the next generation. And the key to that is reusability. So when you, if you do the math, it's very simple, but the cost of the propellants in these launch vehicles is trivially small. On our new Glenn vehicle, we're building an orbital vehicle that's going to launch out of the Cape on pad 36. That vehicle has a couple of million pounds of liquid oxygen on board. A couple of million pounds of liquid oxygen costs a couple of $100,000. It's not, liquid oxygen costs about 10 cents a pound. It's not very expensive. Our vehicle is liquid natural gas is the fuel. It's also very inexpensive. The cost is we build this beautiful, precise, well-tested aerospace-grade hardware, and then we throw it away at the end of every mission. That's very expensive, and that's what drives the cost of launch. And when the cost of launch is very high, what happens is we reach a certain equilibrium, but it means we can only launch really expensive things. If the cost of launch is high, the cost of the things we launch has to be high. And if we could lower the cost of launch, what you would find is that the cost of the things that we can afford to launch would also come down. And that would change everything. That's a real game changer. And so it can't just be the reusability has to be real, by which I mean it has to be operational reusability, similar to what we're familiar with military aircraft or commercial aircraft, where you really, you don't have to disassemble the vehicle, x-ray everything, reassemble it all after every mission, and flight test it all again and validate everything. It has to be real operational reusability. When you get there, and it's going to take a long time, and it's going to be very difficult and very challenging to get there, but when you get there, it changes everything about space, and that's super exciting to me.
Just in the last 3 days, we've heard about your moon mission. We've heard about Elon Musk's plans to launch a mission around the moon with 2 space tourists, and Richard Branson starting a new small sat launch company. Is there enough room for all of these players and also NASA? Or will there have to be some winners and losers at some
point? I think that there is plenty of room. Again, my experience is colored by watching what's happened on the internet over the last 2 decades. But great industries are made by a large number of companies. And so far, I think the global record is 13 people simultaneously in space. So I think there's room for multiple companies.
I'd like to end the evening by... asking you to take out your crystal ball. You were 5 years old when Neil Armstrong landed on the moon. 48 years from now, what's this industry, in the next 48 years, what's this industry going to look like, and who's going to be doing what?
Well, 48 years from now, difficult question, challenging question. What I would say is, one thing that I believe, and I don't know the exact timeline, but I believe it very profoundly, is that in order to continue to grow as a civilization, and in order to protect this jewel of a planet, Earth, we need to extend ourselves into the solar system. You can do a simple calculation. Take current baseline energy usage globally, compound it at just a few % a year for just a few hundred years, and you have to cover the entire land mass of the Earth with solar cells. So what does that tell you? Over just a few hundred years, which is not that long, we're not talking geological time here. Over just a few hundred years, we have to do things very differently, or we have to face a world of stasis. And, on the one hand, you have this idea of stasis where we won't increase our energy usage, we won't increase our population. On the other hand, you can go out into the solar system, you can continue to use more energy, you can continue to grow the population, you can have a world and a civilization of expansion, pioneering, growth, invention. Which of those two do you want? Stasis or this growth and dynamism? For me, the answer is obvious. And so you have to go into space. And I think it will take longer than 48 years, but I believe that you'll see over time a great inversion where we humans will build all of our heavy manufacturing in space, and we will reserve the Earth. It'll be effectively zoned residential and light industrial. And the space is a much better place for heavy industry. We have 24/7 access to solar power. We're never shaded by the Earth. We never have nighttime in space. There are, for all practical purposes, limitless resources in space, and we can continue to grow our civilization. So to me, that's a very exciting idea. And by the way, we have now sent robotic probes to every planet in this solar system. And believe me, this is the best planet. This is the one. And it is our home. And the way we can protect it and keep it, the jewel that we evolved in, is to expand out into the solar system. And so we need to keep working at that. Our motto at Blue Origin is Gradatum Ferociter, which means step by step ferociously. These things take time. I don't believe in skipping steps. I think that the tortoise always wins. I like the old military saying, slow is smooth and smooth is fast. That's how we get there. But we do have to keep going, and we do have to work at it. We can't stop. The world is getting to be a place we do need to go into the solar system. So that's very motivating for me.
Okay, well, you're right, 48 years is a long time, but I'm really going to enjoy watching the next year because I think you guys are going to be doing some really cool stuff.
Thank you. If I could say one thing, especially to the young people in the audience, I went to the restrooms earlier, and there's something remarkable over by the restrooms that especially the young people should check out. It's a payphone. There is, and I am not making this up, a payphone in that corner. I recommend you check it out. It may be your last chance.
Well, this is a museum. So, Jeff, thanks so much. And you're on that note.